the sum of the terms in an arithmetic progression. There's actually two formulas for this. The formula that your book gives is this one here. So if I'm looking for the sum of the first n terms of an arithmetic progression, with first term A and common difference D, that's the formula that you could possibly use. There's another formula that was given. This formula, the sum, is given by n times a sub 1 plus a sub n. So basically the first term of the sequence and the last term, whatever that term is. If it's if you're looking for 25 terms, it's the 25th term. If it's like you're looking for 30 terms, it's the 30th term, whatever. N being the number of terms. If you follow this formula, that would calculate the same thing. These are good for different circumstances. The first one, the one the book is good if the nth term is not known. If I don't know what the last term of the sequence is or I haven't found it, that's the one I want to go with, because I mean that would require an extra calculation. And actually part of the calculation of finding that nth term is in that formula. Whereas if I happen to know what the nth term is already, the second one is also a formula. So I mean, if you were asked to add the numbers, 1 through 100, you know what the first term is, you know what the last term is. You notice that the common difference doesn't play a role in this because, if you know how many terms that is, and you know what the first and last terms are, that kind of hides the information of what your common difference is, because you can kind of figure that out. I would use that second one. So, depending on how you approach this problem that we have here, find the sum of the first 25 terms of the following sequence. If you notice, that's the same sequence we have in example 1. So, you could use either formula here. So as I look at this particular problem, I do know that, if I was approaching it and I hadn't done example 1, I would look at this and say, okay, n equals 25, d equals 3.5, a sub 1, or a, depending on which formula you're using, the first term is 5. Now, if this is the only problem I was given, if I was to say, hey, here's the problem, we didn't do the previous example, then I would probably go with this first formula, because I don't know what the last term of the sequence is, and I had to calculate it. It just so happens, though, in example 1, we did calculate what a of 25 is. And we know that's 89 based off of the last thing we did. So with these circumstances, it's actually easier to use the second formula. And if I use it, I'm just plugging the 25 in for n. A1, the first term is 5. The nth term, or 25th term, is 89, all divided by 2. And when I work that out, I get 1,175. Just to show you, though, if we had not done example 1 first, I said the first formula would have probably been more appropriate because we had not calculated the last term of the sequence. So if I plug this formula in as well, I'd still get 1,175. That should be taken for granted. We should know that either should produce the same results. It's just the circumstances you might be presented with determine which one you want to use.